Hey everyone, I wanted to make this video to talk about the discussion board that we just completed and make sure that everybody feels good about this material because it is certainly important material and it almost serves as like a little review of everything we've done so far. So if we just remind ourselves of this context, the context is that there was a freeze in California's Central Valley in 2007 and it wiped out 75% of the citrus crop. Not good, right? And so what we're looking at is the cost then of certain citrus fruit could be a function of just what percentage was frozen, because certainly supply and demand, right? So if a lot gets frozen, then the price might go up. And so what we have here is we're given a hypothetical functional relationship between the cost of the citrus crop and the percentage that is indeed frozen. And that functional relationship is given by this notation right here, that C is a function of P. Cost of the citrus crop is a function of the percentage that was frozen. And so you can, see the variables being defined for you right here so that you know which is which. And play on words for function notation, right? The input quantity is always inside the parentheses. So the input is in, and that would be the percentage, because the percentage is the variable that's inside the parentheses. And then the output quantity, output is out, play on words. So this output quantity is the quantity on the outside of the equal to bar. And on that particular function, that is going to be the variable C. So for part A, we're just acknowledging that fact right there, that the input is that variable P. And again, in this context, it stands for percent of crop that's frozen. And then the output variable, as mentioned, is the letter C. So the output is C. And what that stands for is the cost of the crop, so the price. And specifically, it's of a box of oranges. All right, so just identifying which is which is a very important starting place. Okay, so then to write a formula for the linear function itself, we need to find the rate of change to start, right? So a linear function is held together by the glue that is the rate of change. So what I like to do when I'm doing these, and it's one of the hints, if you will, that was given in this, is I like to organize my data in a table. It just helps me picture the quantities, and it allows me to visualize not only the input and the output, but then also which variable, or not variable, but which values are which. So if the input is P and the output is cost, if we go back and we look at this scenario and what was given to us, we're told in that paragraph that when 20% of the crop is frozen, the cost for a box of oranges was $11.58. So those values go together. When there was 20% of the crop frozen, the cost of a box was indeed $11.58. So that would be one ordered pair that goes with this situation. If you keep reading, we find out that when 80% of the crop is frozen, the price goes up to $25. So those two values also go together. When 80% of the crop is frozen, the cost goes up to $25.32. Okay. So again, just organizing my information so that I can figure out my constant rate of change. So now to figure out my constant rate of change, we need the change in the outputs divided by the change in the inputs. And in this particular context, that would be the change in price divided by the change in percentage. So for the change in cost, I'm looking 11 to 25.32, 11.58 to 25.32. How much did it change by? Well, we can subtract those values and find out. So whatever 25.32 minus 11.58 is, that will tell me the change in the price of a box of oranges. Similarly, the change in percentage from 20 to 80, well, that one I can do in my head, it's 60. But certainly I could just do 80 minus 20, and I would get 60. So then I'm just gonna grab my Desmos here to do that top numerator for me. So if I take 25.32 minus 1158, 11.58, I get 1374. Again, divided by 60. So my constant rate of change for this context after I divide by 60 is 0.229. 0.229. If you were to round that, I would say 2 decimals is appropriate. So we could do 0.23 if we wanted to. 0.23. Either one is acceptable. If ever I'm being super picky, the directions would just be very clear. And the directions would say, hey, round to 2 decimals or whatever. Okay, so that's our constant rate of change. Now, the directions, though, for part C are to create a function, a linear function formula. So this is where we now have the option of either doing a croc x plus vi, an mx plus b style, or maybe we'll just use a reference point in this formula, and then I won't have to worry about finding the vi. So for me, in this particular context, I would probably just use a reference point. So we can choose whichever reference point we want. For argument's sake, I'm going to use this top one. So just for the sake of my answer key here, I'm going to use that ordered pair right there as my X reference and my Y reference. And so then if I hop into my, essentially the skeleton is f of x equals constant rate of change times x minus x ref plus your Y reference value. And so in this particular context, though, we're not going to use f of x. We're going to use the variables that are given. So C of P, C is a function of P. That would be the expanded notation, if you will. Oh, actually, you know what? It was chosen for me. It's G. So the function name was already chosen. So we will go ahead and be consistent. So G of P. My constant rate of change is 0.23. Again, input variable is P minus, okay, my X reference point, my input reference point. So that would be this guy right there. So I'm going to have 20 plus my Y reference value, my output reference value. So that would be this guy right here. So plus 11.58. Now, in terms of anybody who wanted to find the vertical intercept for this situation, you absolutely could. There would be 2 major ways of doing it. Option 1, just for the sake of highlighting your options, if you really wanted to get the vertical intercept, is you could say to yourself, okay, building from that 20%, gosh, I wonder what the cost was if nothing was frozen, 0% frozen. So you can imagine going backwards 20 units in order to figure out the change in X necessary to get from 20 to 0, be negative 20. Times, of course, the rate of change. The rate of change tells us that the price goes up essentially that many dollars per percentage. That's the units on that, dollars and percentage points. So for every single percent, the price goes up 23 cents. So if you go backwards 20%, well, then the price would have been cheaper too. How much cheaper? Well, let's times it by the rate to find out. So again, I'm just going to grab my Desmos and do negative 20 times 0.23, and you get negative 4.6. So negative 4.6 is not the final answer. That just tells me how much the cost would have changed. So if we could rewind the clock by 20 percentage points, well, then the crops should have been $4 cheaper. So then to get the actual cost, we'll take that negative 4.6 and add it onto our reference cost. So again, I was building from this ordered pair. So 1158 is my reference cost. So 1158, add those up, plus 1158, and the vertical intercept would have been $6.98. So if you wanted to, 6.98, there we go. If you wanted to find the vertical intercept, you could this is one option, right? So just to work backwards 20 units, delta X, or in this case, delta P is -20, -20 copies of the rate tells you how much the cost would have changed. Subtract that from the original cost or from the reference cost, and poof, there you go. The other way to get that same value would just be to distribute all of this and combine like terms. If you distribute fully that equation and then combine like terms, you will also get 698. So an alternative formula for anybody who wanted to do it this way, an alternative formula using the vertical intercept, C is still a function of P. The rate of change is still 0.23, but now since I'm in Croc X plus VI form, it would just be P plus my vertical intercept of 6.98. These are both completely appropriate answers. I would always accept either one of those. So maybe at this point, my hope would be that you're just finding one option that maybe makes the most sense to you and just sticking with it, you know, maybe. So either way, there's two answers to part C. Okay, part D, identify a practical domain, and then part E, identify a practical range. Okay, so domain and range. Well, when we're thinking about practical domain, remember again, domain in input, domain in is what I would say to my in-person students, domain inputs. So we're asking ourselves, what are some practical values for the input? Well, in this particular context, remember the input is percentage. So when we're imagining practical values for domain, we're imagining practical values for percentages. And in terms of real world, right, your percentages have to kind of cap out from either 0 to 100. Now, since this model was built in percentages, you are allowed to, by the way, just leave them in percentage form, meaning 0 to 100. I know some people were wanting to do 0 to 1, and I can totally understand why. But since this variable is literally defined as the percentage, we really are talking about percentage points, 20%. Notice I'm not using 0.2. No, it's defined as percentage. So you can simply just say anything from 0 to 100 would be reasonable. Now, when you write this in notation, some of us like to use interval notation. So from 0 all the way up to 100, that would be interval notation. The brackets indicate that we are including those values. We are imagining that it's possible that nothing was frozen, and we are imagining that everything is frozen. Those are definitely the two extremes. Or if you wanted to use inequality notation, you would say 0 is less than or equal to the input variable, which is P, which is less than or equal to 100 on the upper end. So that's how we could identify a practical domain. And I justified my reasons, of course, along the way. And then for practical range, here's the thing. A lot of students, when they get to practical range, they're like, well, I don't know. How am I supposed to know how cheap or inexpensive, in this case, the cost of a box of oranges is going to be? Okay, I hear you. You don't know. But here's the expectation. Your range should correlate to your domain. So what I mean by that is when you start thinking about your practical range, so this would be the costs, right? You have to ask yourself, well, what would the cost have been if nothing was frozen? Those need to correlate. And what would the cost have been if everything was frozen, 100% of the crop was frozen? Now, admittedly, if everything was frozen, then do we even have oranges to sell? Interesting perspective. Maybe not. So as I'm thinking about it, we might decide to not go that extreme. And let's at least hope that there's something left. So I just now changed my domain to go all the way up to 100, but not quite including 100, because if everything literally was frozen, then I don't think I'm even selling oranges anymore. Okay, so check. We made a small amendment there. So either way, these are the two costs that we have to imagine. So we already found, thanks to my scratch work, that if nothing was frozen, then the oranges would have cost $6.98. We already found that. In doing our vertical intercept work, we already knew that. If you did not have that number already, you would just use your function model and plug in 0. Plug 0 into your function model and you will get 698. So you just plug in 0 right here, or plug in 0 right here, depending on which formula you wrote. Okay. But we already had it. And then I would also need to know, in order to correlate, what G of 100 would be. So I'm going to do that really quick. And just because it looks easier, I'm going to use this formula. So I'm going to grab my Desmos and I'm going to plug in 100 for P right here. I'm going to plug in 100. Let's see what I get. So I'm going to take 0.23 times 100 for 100% plus the 698. It would have been 29.98. 29.98. So that right there tells me my upper and lower extremes for the cost of a box of oranges. So again, assuming that nothing is frozen, they would have been 698 all the way up to, but not including everything frozen, would have been 29.98 up to, but not including. So notice the parentheses. Or if we wanted to do inequality notation, it would be 698 less than or equal to my output variable C, which is up to, but not including 29.98. Okay, so again, on this one, I think most people are able to wrap their brain around 0 to 100% being practical, but it's that cost that a lot of times students are like, well, how am I supposed to know? Yeah, I know, I hear you. And that the answer to that is you're just supposed to correlate them. So if your domain starts at 0, your range starts at whatever the output is of 0. And if your domain stops at 100, then your range stops at whatever the output is at 100. Okay, so there's D and E. What's next? Explain the meaning of G inverse 12. Okay, so without having to do any actual formulas yet, G inverse of 12. Well, remember, for inverse functions, the input and the output are simply reversed. So if the original function was cost is a function of percentages, well then in the inverse formula, percentages would be an inverse function of input cost. And this is the one that we are imagining for part F. So for G inverse 12, 12 is the input to the inverse function. So 12 would have been the cost of the oranges. So $12 is the cost for a box of oranges. And that's it. We didn't have to evaluate. It doesn't say evaluate. It doesn't say solve. It just says explain the meaning. We'll evaluate it later in part H. But for now, it just says explain. So we did. 12 would be the cost of a box of oranges. Now for part G, you are officially invited to find the inverse, determine the inverse formula. So notice in the inverse formula's notation, P is now on the outside. We have inverse notation on the function name G, and C is now inside the parentheses because C will be the input to our inverse. So whenever you're finding an inverse, you always just start with the original formula. So if I were starting with my, I guess let's do this top one, this one right here. If I was starting with that formula, I would just have cost was my original output, 0.23 P minus 20 plus 11.58. So whenever you find an inverse, you always just start by writing down the original problem, and then you invert every operation until the other variable is by itself. So in this case, in order to inverse every operation, I'm going to subtract 11.58. And remember, inverse formulas are just that. They're formulas. So you're not going to actually be able to compute this numerically. You're just going to represent it algebraically. So it'll say C minus 1158 equals the 0.23 P minus 20. Okay, I've still got my focus on that variable, so I'm going to divide off the 0.23. So now I'm at, let's go over here. So now I'm at C minus 1158 all over 0.23 is equal to P minus 20. So the very last step would be to add 20 to both sides. And again, we're just representing this algebraically. So you just have this giant expression, C minus 1158 all over 0.23 plus 20 equals P. And that right there is the inverse formula. Notice by the time you're done, P is now on the outside. Yeah, that's the whole point. Remember, P used to be the input? Remember that? Yeah, not anymore. Now it's the output. And the variable C, remember C used to be on the outside? Yeah, not anymore. C is on the inside of that expression. So that's it. Mission accomplished. That's the inverse right there. If we were to do those same steps using the other formula, do I have room? Let's make room. We're going to go up here. So if I were to rewrite the other formula really quick, the C equals 0.23P plus 6.98. That was my Croc X plus VI option. And if I were to invert that puppy, it'd be a little bit less steps. So admittedly, that one might have been the easier choice, but I wanted to show both. So it'd be C minus 6.98 is equal to 0.23P. Divide both sides by 0.23. And I ran out of room, so we'll go right here. It would just be that expression. So C minus 6.98 all over 0.23 equals P. There's a P there. That looks really sloppy. Let's try to make room for it. Equals P. There we go. Okay. And again, don't mind my unorganization of the page, but this guy right here is an alternative answer for the inverse. Same as before. P is now on the outside. Yes. C is now on the inside. Yes. Mission accomplished. Option 1, cool. Option 2, cool. They both work. Okay, and then for the last one, I'm going to need a new little sheet of paper here. For the last one, now we do officially get to evaluate the G inverse of 12. Now, what's cool about evaluating G inverse of 12 is, let me get a new page. Can I do dots still? Where's my dots? I guess it doesn't matter that much, but I thought I'd be able to use my dots again. Oh, well. Oh, that's my dots. Okay. So if we're doing G inverse of 12, well, now at this stage in the game, we have the formulas for the inverses, remember? So one of my inverse formulas, I'll use the purple one, C minus 1158 over 0.23. So C minus 1158 over 0.23 plus, I think it was 20. Yep, plus 20 equals P. Okay, that was one of my options. And if I wanted to, I could use that right now to plug in 12. Plug in, literally plug in 12 to the inverse right there. Plug it in. So I would just literally replace the letter C with the number 12. And I would just have to grab my Desmos, carefully type this in, making sure that my fraction is set up properly and all that jazz. And I would get an answer. If I wanted to use the other formula, the C minus 6.98 divided by 0.23. So what did I just say? C minus 6.98 divided by the 0.23. That one, that was also the inverse formula. This is also the inverse formula for this model. So same idea. I could take the 12 and plug it in for C. So we could do that. In this case, it would say 12 minus 6.98 all over 0.23 is equal to P. I would double dog dare you to evaluate both of those, and you will absolutely see that you get the right answer. So I'm going to do the one on the left. So 12 minus 11.58. I'm in Desmos, not my iPhone calculator. iPhone calculators are the devil. Don't use it. Use Desmos. Okay. I'm off my soapbox. Did you enjoy it? Good. Let's come back. 12 minus 11.58. I'm going to divide that puppy by 0.23. And then I'm going to be very conscious to tap outside of the fraction and say plus 20. See, in Desmos, you can see for yourself that everything is exactly where you want it to be. I can see my fraction bar. I can see who's on top and who's on bottom. The plus 20 is on the outside. It's all very, very clear. And my calculator says it's 2182. 2182 is the value for P. So what does this tell me? Well, remember we said before that when you do the inverse of 12, you're saying that 12 is the cost for the box of oranges. And that's still true. We plugged in 12 for the cost of the orange. And now we have found the percent that must have been frozen. So to fully wrap our brain around this, we could say the cost of a box of oranges, is $12 if 21.82% of the crop is frozen. That is what that means. And again, I'm going to double dog dare you to plug that in. You'll still get 21.82. The answer is the same. Okay. So that's where, once you have an inverse function, certainly you can plug stuff into it. Just like you can plug stuff into regular functions, of course you can plug stuff into inverse functions. That's the whole point of finding them sometimes. Okay, I think that was all of them. Is that all of them? Yeah, evaluate G inverse of 12. We did that, talked about it, nailed it. Okay, well, hopefully that was helpful, guys. If you have any questions at all about some of the things that we just now did, going over that discussion board, please reach out to me, talk to a friend, talk to a tutor. Definitely make sense of it though, because these ideas are absolutely the kinds of ideas that are fair game on our first exam. So thank you guys again, and we'll be in touch. Thanks.